This is lesson 3.1, Solve Linear Systems by Graphing. Some of you like to just watch without actually hearing what I'm saying, so if you're watching this video, please make sure that you listen and not just watch. Okay, I have lots of little things to tell you. Let's say we had this given as a problem, and all you see is 4x plus y equals 8 and 2x minus 3y equals 18. And the directions say solve. Okay, well, that means probably nothing to you. How do I solve this? What does it even mean to solve this? So if you were to take maybe some things that you have learned in the previous lessons, you know that we could graph this. It's a line. We have to get it into the right format, but we can graph it. And we can graph this one. It's also a line. And maybe that'll give us a hint of what's going to happen. Okay? So that's where I'm going to begin. First of all, I'm going to take 4x plus y equals 8. So I'm going to subtract 4x from both sides. So I have y equals 8 minus 4x. Okay? And I'm going to come over here and make myself a graph. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. That's going to be my starting point. And then my slope is negative 4. So down 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. Kind of hard to see these. So that would be at 1, and that's going to be at 2. So we've got negative 1, negative 2. And so forth and so on. Okay, so my graph goes from here to here to here. And you can probably tell I'm not the greatest grapher, and I miss my dots just a little bit, so I'm going to color them in a little bit better. Okay, now I'm going to look at this line right here and get y by itself. So subtract 2x, subtract 2x. That gives me negative 3y equals 18 minus 2x. Now I'm going to divide by negative 3, divide by negative 3, divide by negative 3. So simplifying this, y equals negative 6 plus 2/3 x. So I'm going to start at negative 6. 1, 2, 3, 4, 5, 6. That's my starting point. My slope is up 2 over 3. And up 1, 2 over 1, 2, 3. Trying to make this look like it's about right. Okay, I'm going to connect these dots. Okay, so the directions were to solve. I did the only thing I knew to do, which is graph. I have these two lines, and now I'm trying to find a solution. Well, there is a solution here. Where these two lines intersect each other is going to be where my solution is. So, when these two lines intersect, they intersect at a point, and whatever that point is, they both have that same x value and they both have that same y value at that point. So it's kind of hard to tell, but that's actually here and here. So my x value is 1, 2, 3, and my y value is negative 1, 2, 3, 4. So my solution is x equals 3 and y equals negative 4. This is called a system of equations because there's more than one equation. This is specifically called a system of lines because we've graphed more than one line. And whenever they intersect, that's where the solution will be. Alright, let's try another one. Now that we know what our goal is, we're going to try graphing these and see what happens. So, I'm going to start with this first line. I'm going to subtract 2x and subtract 2x. So y equals 4 minus 2x. Okay? Then I'm going to come down here and make myself a graph. And I'm going to go 1, 2, 3, 4. And my slope is down 1, 2, over 1, down 1, 2, over 1. For some reason those dots are hard to put. Okay, so if I connect my dots with my not very straight line, there's the first line, which I guess I could have put that first line in red. How's that? Okay, for the second line, we're going to subtract 2x and subtract 2x, so y equals 1 minus 2x. So I'm going to start at 1. I'm going to make this graph green. So I'm going to start at 1. My slope is down 2 over 1. Down 2 over 1. So I'm going to draw my line. Looks like this. And this looks like this. Okay. So these two lines have no intersection. They don't ever intersect each other because they are parallel. Since they don't have an intersection, they have no solution. Solution. That's an O, solution. Okay? So parallel lines have no solution because they do not intersect. Okay, well that was easy. We solved that system of lines. Let's try another one. Let's bring this over here. 4x minus 3y equals 8, so I'm going to subtract 4x, and I'm going to subtract 4x. Doesn't look very good. So I get negative 3y equals 8 minus 4x. I need y to be by itself so I can graph it. Divide by negative 3. Divide by negative 3 all the way across. That's not a very pretty one. Okay. Y equals negative 8 thirds plus 4 thirds x. Bleh, that's not very pretty. Okay, let's see what this other one's going to be. When we rewrite this, I'm going to subtract 8x, and I'm going to subtract 8x. So I have negative 6y equals 16 minus 8x. Then I'm going to divide by negative 6, divide by negative 6, divide by negative 6. Y equals 16 over 6. This is negative. 16 over 6 reduces to 8 over 3. Negative 8 divided by negative 6 is positive, and 8 over 6 reduces to 4 over 3x. Well, what do you notice? This equation and this equation are the exact same. So we started with two equations. They didn't look like they were going to be the same equation, but after we did a little work, it turned out that they are exactly the same. Okay? So what this means is that we have the same line twice. So if we have the same lines, then they are going to intersect the entire way because every single dot is going to be a solution. So when you have two lines that turn out to be the same lines, there are an infinite amount of solutions. Okay? So what I've shown you are the three examples that you can come across. You could have one solution where there's an intersection, and that point where the point where they intersect is the solution. You could have no solution, and that's what happens when you have parallel lines. And you could actually use this symbol for no solution. Or you could have an infinitely many solutions. That's what happens when you have the same line twice, or the lines are the same. And if infinitely many solutions is a lot to write, then you could use this symbol right here, which you've seen before, and that's a sideways 8. Okay? So you're either going to have one solution, no solutions, or infinite solutions. Those are your only options when it comes to graphing systems of lines. Okay, here's a problem for you to try on your own. Draw yourself a graph. It doesn't have to be beautiful. and see if you can see where these lines cross or see if they intersect at all.